I'm Anil Kumar, and here is an interesting question on right triangles. The question is, solve for the height h and the angles alpha and beta in the figure given below. So we have two right triangles. One right triangle is ABC, the other one is ABP. We need to find the angle alpha and beta shown here, and the height, which is D2E, right? That is what we need to find. You can pause the video, answer the question, and then look into my suggestions. Now let's begin by finding the angles first, the angles alpha and beta. Now if you consider the triangle ABC, then tan of alpha is equals to opposite side of 8 divided by adjacent of 6 is 8 over 6. So we can use calculator and find alpha as tan inverse of 8 over 6, correct? Now if you consider the triangle ABP, so let's consider the triangle ABP. In that triangle, you can say that the tan beta is equal to opposite side of 15 divided by 6, correct? The adjacent side. Exactly same steps. So we get beta equals to tan inverse of 15 over 6. So we can find both the angles using tan inverse, right? So let's use the calculator now, find the answers. So the first one is tan inverse of 8 divided by 6. That is equals to 53.13. So let's round this to one decimal place, right? So 53.1 approximately. The second one is tan inverse of 15 divided by 6 bracket close equals to 68.19. We can write this as 68.2 degrees. So both are in degrees. So that is how we can find the angles alpha and beta. Now let's see how to find the height h. Now to find height, we can actually use similar triangles or we can use trigonometry. Either way we can find. Let's use similar triangle in this case. Now all these are perpendicular, right? So if you look at this big triangle, then since DE is parallel to PA, we have two similar triangles. So the ratio of their sides are in fixed proportion, correct? Similarly, the ratio of the sides for ACB and ADE should be in fixed proportion. So that should help us to find the height h. So we can use similar triangles also to find h. So for that, let us assume that AEB total is 6, right? So if I say E to B is x, then this distance will be 6 minus x. Do you get the idea, right? So AE, so we say AE equals to 6 minus x if EB equals to x. They total to 6, correct? So let's do that, and then we'll find the height. So let us use similar triangles and find the height. So from this big triangle, we know that triangle APB is similar to triangle EDB. So in that case, the ratio of the sides, that is 15 over 6, should be equals to h over x, right? H over x. Now, so from here we can write what x is in terms of h, right? So let us write down. This implies x is equals to h times 6 over 50. Is it okay? So let us find what x is in terms of h. So 6 divided by 15 is 2 over 5 in decimals, 0.4, right? So we have x is equals to 0.4 h. Okay. Now let us consider the other triangle, which is triangle ACB and triangle ADE. Now these two triangles are also similar since they have parallel lines in between. Angle A is common, 90 degrees. From AA we say they are similar triangles. So ratio of their sides is also constant or same. So it is 8 over 6. We can write 8 over 6 is equals to h over 6 minus x. Correct? Now what we can do is, we know x is 0.4h, so we can write 0.4h here and then find what h is. So from here we can solve the equation. So 8 over 6, let us write in decimals. So 8 divided by 6 is equal to 4 over 3. Okay, let's use anyway. 4 over 3 means 1.33 recurring. So we can say, let's cross multiply. So 8 over 6 is 4 over 3 or 1.33, right? Let's use two decimal places. Times 6 minus x is equals to h. Now x is 0.4h, so we'll replace x with 0.4h. So we'll 1.33 times 6 minus 0.4h equals to h. So we have now a linear equation in terms of h which we can solve, right? So let's open this bracket. It is 4 over 3, so okay. So we have 1.33 recurring. We'll multiply that by 6 times 6 is equal to 8. So we get 8 minus 1.33 recurring times 0.4 is equal to, in decimals, let's write 0.533. 0.533h equals to h, correct? Now let us solve for h. So let's do it here. So the equation will be, let's take these terms on the right side. So we get h plus 0.533h is equals to 8, or 1.533h equals to 8. So h is equals to 8 divided by 1.533, right? So let's divide 8 by 1.533, which is equals to 5.2. So we get 5.21, which is approximately 5.2, right? So the height will be 5.2, units will be meters, correct? Since all the dimensions are in meters. So that is how you can find the height, right? You could also use tan ratios to find height. Since we have calculated the angles, once you have calculated the angles, we could use tan ratios. But in this case, I prefer to use similar triangles. As you can see, it helps. I hope that helps you to solve such questions. Thank you and all the best.